Hello there. In this video, we're going to be looking at sets and the notation that we use for sets in maths. So what is a set? Well, a set is simply a collection of objects. Now, this could mean pretty much anything you can imagine. This could be numbers, so 1, 2, 3, etc. This could be the cities in the UK. This could be different breeds of dogs and cats. It can be pretty much anything you like. And the notation that we use for sets is that we open up a curly bracket like this, and then we fill in inside the set with what we call elements. So if, for example, I write 1, 2, 3, 4, 5, and then close this off to mark that that's my set, then we would say this is the set which has the numbers 1, 2, 3, 4, 5, and we would say that 1, 2, 3, 4, and 5 are all elements of the set. The notation that we have for an element is simply by saying, well, let's define this set as, say, A, right? This will be the set A. I could say, for example, 2, and this symbol here, which sort of looks like a little euro sign, is like a sort of C with a line in the middle. So 2, and this symbol here means is an element of, and we will say the set A. So what this means is that you will find 2 in the set A. So we say 2 is an element of A. If, however, I take the number 6, then since 6 is not within the set A, we will write this symbol, but then put a cross through it to say that 6 is not an element of the set A. So in maths, what we've actually found is that there are some sets which are of particular use in many areas. I'm going to call these special sets. And let's get into that. So the first set I would like to introduce you to is the natural set. And this is the simplest set we'll see here. So we denote this set with the letter N, but it's a sort of fancy N. So we have an N here, and then we just kind of make this line here. And this set will equal the numbers 1, 2, 3, and that goes on. So you'll have 57, 1,042. This will carry on to infinity. And you just plus 1 from starting from 1, you just plus 1, and those are all the numbers in the natural set. So then we have the whole set, and the whole set is denoted with a W, and this will be equal to basically the natural set, but we include 0 in it. So you notice in the natural set we did not include 0, but in the whole set we do. And it carries on to infinity just like that. The next set we'll look at is the integers, and we denote this with a Z. And the reason we denote this with a Z is because the word for number in German is Zahlen, so that's where that derives from. Now, the integers are the whole numbers, but then also the negative versions of that. So we can have -3, and then it will go even more than that. So first of all, so -2, -1, 0, then all of these, so 1, 2, 3, and that carries on to infinity that way, but it also carries on to infinity this way. So you can have -1,042, -1,006,006, and it goes all the way down to negative infinity and also upwards to positive infinity. The next set of numbers we'll look at is the rationals. So with the rational set, it's in the name, ratio. So what the rational set is all of the numbers that we can write as a fraction by dividing two integers. So we denote this set with a Q, and we denote it with a Q because it's Q for quotient, and quotient is division. So this Q will equal all the numbers that have been written as a fraction. So we could have like -3/2, we could have -1/2, right? You could also have 0 as well. You could have also 1, because remember, all these numbers we can just divide by 1 and we'll get that again. So these can all be expressed as all be expressed as a division of two integers, and we could have 17/28. We can have all kinds of different things, but essentially it's all the numbers that you can make by dividing two integers together. The last set, and perhaps the one which we'll use the most often in higher maths, is the reals. So the reals is denoted by an R for reals, and this is the set which includes all of these. So essentially it has the rationals, integers, whole set, all of these, and also irrational numbers. So irrational is simply the opposite of rational. Rational means that we can divide two numbers and make it, then irrational means it is a number that we can't divide two numbers and make it. So an example of that would be, say, pi. So you cannot find a fraction in maths which will equal pi. It's not possible. So we could have, for example, here minus the square root of 17. You'll never find a fraction that can represent that number exactly. And you could also have minus the square root of 2, 0, 1, 2 as well. And you could also have, say, pi. You could have pi squared. I mean, you could have all kinds of things in here. Now, something important to keep in mind is that these sets all build on each other. So the whole set of numbers has everything the natural set has plus another thing. The integers has everything the whole set has plus some negative numbers. Rationals has all of these integers in it, then plus some more numbers. Then the reals has all of these numbers in it, and then also all the rationals in it as well. So they all build upon each other. And so you'll commonly see this diagram, which looks something like this. There we go. And you can see here that basically all of the numbers in the natural are encompassed by the whole set, then the integers, then the rationals, and then the reals, which include the irrational numbers.